What's up, everybody, and welcome to this week's episode of Firepunk Friday. I've got a good episode lined up for you this week, and it's been a crazy week here at the shop trying to get ready for the steam threshers this weekend. We've got a truck class of sled pulling that we're hosting, and then we're also hosting about 75 old tractors and the farmers that like to ride them for lunch on Friday. So we're trying to get everything cleaned up around here and get some food cooked for them. So looking forward to that. It's a highlight for us every year. And then we're also going to participate in the parade Friday night and, be at the show all weekend. So a lot of fun for us, a local event where we're able to give back a little bit and interact with the locals and the people that come from out of state to enjoy the show as well. So, it's a good week around here. Lots of work going on, aside from that as well. So I've been trying to keep up with everything, and I don't do the greatest job of that all the time, but so trying to balance everything, and then doing Firepunk Fridays is always a nice little getaway for me. But this week we're going to talk to Johnny Gilbert from Stainless Diesel. Had a great conversation with him, and hopefully you guys can learn something from our conversation and talk to anything from race cars to turbos to wastegates. But here's Johnny, and hope you all enjoy. All right, today we've got Johnny Gilbert with us. What's up, Johnny? How you been?
How you doing? Doing well.
Yep. You all staying busy over there?
Oh yeah, definitely swamped and covered up, and all the good stuff here at the shop, and all the guys are rocking and rolling.
Yeah. What are some of the challenges you guys are seeing with business nowadays? Like, you guys, I'm assuming you fight to get parts like everybody else does, or you guys pretty good with making your own stuff and keeping on rolling?
So along the lines of making our own stuff, at least we can kind of plan out when we want to get castings in, like for manifolds, for instance, or turbo covers. And then try to plan ahead with the foundries. And we've been very fortunate with the manifold castings. They get cast in Muskegon, Michigan. And earlier this year, we sent a bunch of POs out, and they hit our timeline targets. So been very fortunate there. As far as getting aluminum chunks to machine for different apparatuses, that's been a challenge for sure. Aluminum pricing has went up, and it's been more difficult to get here for sure. So,
yeah. Well, cool. I figure we'll kind of talk maybe some race cars and talk a little business and talk some twin turbos and maybe a couple other things. But I'd say, why don't we start out a little bit? Let's tell people a little bit how Johnny Gilbert got into diesel and diesel performance and racing and that kind of stuff. Were you a motorhead before you got into diesels, or how did that all go?
Yep. So I was pretty much a Chevy guy. So in high school, I had a Chevy Camaro, and then kind of ended up right out of high school, I got a Chevelle big block Chevy thing. So I've always been geared towards a hot rod, anything. If it was a lawnmower, I'd make it go fast. For the most part, but I got into semi trucks. My dad was a truck driver, so bought my first semi from my uncle, and it was about 22 right in there, and drove semi truck for 13 years roughly. And then in that time, I drag raced my Chevelle and made things go fast, and had to work on the semi, fix it, changing injectors and brakes and all the stuff we could possibly do ourselves. We would do it. And then that kind of led us into getting the pickup trucks, with Cummins motors. And we were very fortunate to kind of me being a Chevy guy. I looked at the Duramaxes first, and I was like, wow, there's a lot going on under that hood. And basically got some Cummins pickup trucks, the first truck, old 12 valve, and hooked it to a gooseneck trailer and figured out really fast how the fuel plates work and things of that nature. And ended up hiring some guys as contractors to pull RV chassis. So we're in the RV capital of the world here, where they make all the fancy names, Forest Rivers and Coachmans and all of that good stuff here. And I had hired a gentleman that had an old turbo kit. It's a HX35 and an HT3V. So that's one of those old Cummins 350, 400 Cummins turbo, and it was reversed rotation compared to like an S400 today. So I looked at that and I'm like, wow, that's neat. And I just started dabbling in making piping. I didn't really have, I just wanted to make one for myself, me being kind of a gearhead. And that's kind of how stainless diesel started. Started making piping, started, fixing turbos. And on our work trucks, we ran into trouble, essentially cracking manifolds. Cast iron, being what it is. I did a bunch of research and found a foundry there in Muskegon, Michigan to do some steel specialty stuff for us. And we were off to the races.
Okay. Yeah. So, yeah, it sounds like a story, a lot like, starts out of necessity, and you want to go fast. You want to make things better, and then kind of takes a direction of its own. And it's kind of crazy how businesses can start from something what you didn't really have much of an intention to do at first. But kind
of a side hustle that turned into the main hustle.
Mm-hmm. So, I mean, the first diesel truck that I remember you having would have been your VP truck that you set records with. I'm assuming that was your first, I don't know, I guess, decent effort at diesel racing.
Yeah. For the most part, I had a 12 valve, a 98 12 valve work truck. Kind of started out with that, and then ended up with a VP truck because I wanted a 4-wheel drive, super clean. Actually got it in Ohio, and I drove it back here to Middlebury, Indiana, and proceeded to break the transmission in half pretty fast. And then at the time, the gentleman not too far from me here, about 2 hours north, Dusty Hawk, back in the day. Some old school names there, HTS transmissions, for anybody that remembers, I guess, 12 years ago or so, 10 years ago. Kind of got into that. And that's when I met John Link, so J&L, years ago. So they were fairly close in our neighborhood. And that's what got me started with the VP stuff. So, yeah. But I did a lot with that truck. It used to be a work truck. I actually towed my Chevelle to the racetrack. When I got that thing running, probably high, like 1190s, something to that range, I started finding and seeking out some diesel races. So,
so you had
fun with it.
I mean, you really took it more to local races even before you, before you got into doing the diesel circuit stuff. But so that truck, I mean, that thing's still like all original. You've still got all the parts on it, right? Like you didn't touch it.
Yeah. So it's one of those things where it starts out really nice with the AC and the daily driver, and it just snowballed from there. So the Pro Street truck basically is that truck. Or what's left of it, rather, just a cab. It's just a cab.
Right.
So, Yeah.
Well, I know that's kind of how we felt with our Pro Street truck. We bought this nice 06. And then in hindsight, we're like, well, why didn't we just go buy a cab and just build the rest of it? Like,
I should have left it alone.
Yep.
But the VP stuff was fun. I mean, we did some weird stuff to it. And that's, I bought my first dyno because I kept going to a buddy of mine's shop in Grand Rapids to test. I'd be there all day on a Saturday changing injectors or changing, turbos and playing with it, and just ended up buying my own. And I'd strap it to the dyno for a month and just wear the transmissions out, wear the pumps out until I could find horsepower. With it.
So at what point did that truck go common rail? Like, I remember your chassis build, but I'm assuming, had you been common rail before that?
No. So the right there at the end of the year at Rudy's, we just did kind of a turbo transformation on the truck, and it ended up being a kind of a trick 6.7 engine. The crankshaft is offset ground to get a little bit more stroke, as far as the cubic inch wise. And we ended up going, because I did low 1100 horsepower range with 2 S300s at the atmosphere and like 1 S400. The trick with the VP is, you don't have a lot of RPM. So we went big cubic inch to try to drive 3 big S400 units. And at the time, try to get everything. I tried to make 100 pounds of boost, and it sounds ridiculous today, but I tried to get 100 pounds of boost by 23 to 2,500 RPMs because the thing would only fuel to around 28, 29.
Yeah. Yep.
And then it just kind of nosed over. So it was
That's
just
crazy.
goofy. No nitrous back then for us,
Right.
but it was interesting.
Isn't it
but
funny?
We broke the crankshaft at Rudy's.
Isn't it funny looking back at some of the stuff we used to do racing and the things that we've learned? Like I remember being at Shy back in the day when we had the Pro Street truck and we were running triples, and I was talking with John Robinson, and we were going fast in terms of Pro Street trucks at that time. I mean, I think we were pretty much on top of the pile. But John told me, he's like, someday you boys will learn. He's like, you might go fast with torque, but you're going to get tired of breaking stuff. He's like, you'll learn to race without torque one of these times. And he was very right.
He was very right. You got that right. Woo. Gosh. Yeah, we definitely broke our fair share of parts. Boy, that's for sure.
It's crazy.
Yeah.
So, and I mean, you guys stuck with the triples for a good little while on the Pro Street truck. And it wasn't until you guys went to the single that you really started going fast. I know. We kind of learned, we tried every trick in the book we could with power management and chassis and tires and springs and 4-link stuff as much as possible. Right.
And then it was like a Sunday drive when I put the single turbo on in nitrous. And the first pass was down at a fairly local track to us, it's US 41 dragway. And basically it felt like probably a 540 pass. And Steve was on the radio. Hey, how fast do you think you went? I said, 540s. He's like, you won't believe it when you see it. It was like a 518 and it just felt like a Sunday drive. So I'm like, no way. So the torque being out of the equation is a huge factor.
Pretty much when you go from, high RPMs and then you go through a shift and you pull the RPMs down and the thing wants to make all the power there. I mean, that's going to rip the tires off. It's going to break parts. It's going to do all kinds of that fun stuff.
Push the crank out the bottom.
Yep.
All of the above.
We never did that. We never pushed the crank out the bottom.
Ooh, gosh.
Only at least twice.
Yep. Yeah. We kicked rods on the ground. We did all that fancy stuff. But
I do not miss the triple turbo days. I just really don't.
Yeah. Just a lot of violence and like in the dirt, I could see why they kind of do it, I guess. And even then, I think if the sled pull guys could run a big single, I think they'd enjoy that.
Well, I mean, when you don't have the ability to use nitrous, they're kind of hand tied. I mean, they need to get as much air in there as they can. So, I mean, I can see how that works. And I mean, a sled pull truck, especially like the super stocks, they won't ever pull those down. I mean, they start sniffing they start snipping 5,000 or 4,500. They're putting the clutch in and calling it quits.
Yeah.
They know their limits on that.
Yep.
So
and then with Pro Street too, it's like I think that the higher we started shifting, really the better we were managing to get down track. I think that really helps and manage that lockup RPM drop. That's a huge deal.
Yeah. Yep. So then, this year we ditched the truck and we got the new car out, and you guys have hit the ground running with that. Had a little bit of some heartache in testing.
The new car gremlins, I guess you want to say.
Yeah. If you don't mind, share your nitrous line story with everybody at testing and kind of how that test day went. How that went ugly and then it went great at UCC.
we were super excited to be able to get it out about a week before UCC. We went down to Jeremy Wagler's track. He was nice enough to host like a good little test day. So there's a handful of diesel guys there. We get there. We've been spool up testing. Here at the shop. The new aluminum engine it's a little bit of a learning curve. It doesn't like to get warm like the cast iron engine. So we tried a couple of our usual tricks to spool. And then once we got that nailed down with some stator changes in the converter, we get down to Jeremy's. Long story short, heating up the bottles, 2 bottles wide open, some Dash 8 line. I'm strapping in the car, ready to drive it up, and a nitrous line broke off of our nitrous rail right in the front of the car. And it's adjacent to our oil tank. And it happened to break the fitting off the oil tank. And, 4 gallons of that wonderful oil went all over the ground, and it made a hell of a racket. And I think Jeremy was up in the box office and said it shook the windows, up there in the tower, basically. And it made a hell of a racket, and everybody scattered. So we got that fixed. Jeremy had some extra lines, so we rigged this thing back up. Took us a few hours there, got some new oil in this thing, capped off where the line did go on the nitrous rail. So we're utilizing just one. Made it up to the line there, did a burnout, and stuck an injector. So never really got a clean pass.
Yeah, some days it just doesn't.
Yep.
It just isn't meant to be. But
it
it's
wasn't our time.
It's also why you go testing to get that stuff out of the way before you show up at the track. And I look back at the way we used to do things, and it seems like we'd show up everywhere untested, and then people wonder why things don't go well. And it's just that's why. It's just you're going to have some of those gremlins. But
I know in Pro Street days we would avoid testing because we weren't sure what we were going to destroy.
Right. Yep.
Or what, so if we're going to break it, we figured, well, at least we'll be at the race when we break it and get some passes in front of people and points or whatever,
Yeah.
But it did not the best game plan.
Right. Yeah. No, it is really nice to know that, starting getting parts under our belts and figuring out how to race to where we can go laps and don't have to worry about breaking things consistently, where you've got to be able to make consistent laps to where you can learn stuff, because making 2 passes at a track and then going to the next track, the temperature's going to change, the track's going to change, you don't know what you don't really aren't able to learn a whole lot when you're not doing things back to back. But
that's for sure. Yeah. And coming from Indy and going straight to Rocky Top, it's a little higher altitude and a hotter time of the year. So that's a lot of guys see some challenges there.
Mm-hmm. Yeah. So Indy, you guys had a great weekend there for, not having made any passes there or not having made any full passes before that. Definitely still some new car bugs, and you guys were, kind of starting from 60 feet and working your way out. But overall, you guys had a great weekend, and I think the car made it back mostly healthy. Maybe a few little things to address before Rocky Top.
It was we didn't expect that weekend. None of us did. I think Junior said it best. He said we just wanted to go a couple clean 330 passes, and as soon as it clipped off on Friday night, kind of a 470, we were like, that was exceeded our expectations to do anything. That weekend when we showed up there, it didn't have injectors. At one point, the injectors were lost from UPS. So there was a little fiasco going on there before, race day. So we fixed it. And like I said, man, got lucky and learned that car and trying to get some data. It made, mostly healthy. As far as we could tell, we didn't destroy anything. We checked the retorque the cylinder head, did the basics. We did tire shake the torque converter bolts loose, so that was fun.
Yeah, it's always a good time.
Yep. So a couple little things like that.
I saw a Snapchat, I think, the other day or something where it looked like you guys had the car outside the shop and we're doing some school tests and stuff, and everything's
burn up a solid state relay. It was on a smaller, so we've got 4 solenoids on it. So one small solenoid, it's a 122 orifice, I think, from that's just Nitrous Express, and then 3 of the 375s on there. And then we were trying to spool off the small solenoid like we do on the Pro Street truck. Essentially, we don't use a jet, and we just pulse width modulate it in and just kind of manage it that way. And we had it kind of working good before we went to Wagler's, and then it burnt up the relay and the nitro solenoid at the same time. So we did some spool up calibration on the Canon and got it to work. It's with no jets. It's this Canon, this -6 line off the 375 straight into crazy little apparatus, and we got it to work okay. But we're recently going back to the small solenoid just to kind of get it to be a little easier to spool without popping banging. And notice we kind of had some popping and banging at Indy.
Yeah,
it was hard to tone it down in the burnout box.
Yeah.
So, guys were jumping off the side of the track and holding their ears, and it was interesting.
Yeah, your rings will appreciate the smaller amount of nitrous during the burnout.
Yes, guaranteed. Yes,
it definitely seems to be the theme of diesel racing right now. Is like, let's not nitrous backfire our stuff so that our rings will live. But
yes,
anyhow, yeah, Rocky Top. I'm looking forward to that. That we always enjoyed going down there, especially Friday nights. They have the gas versus diesel shootout, and it's usually cool, and it's under the lights, and it's a good track, and it's a lot of fun. So yeah, looking forward. Going to be different for us with not having a truck to race, but I'm looking forward to harassing some guys and
there you go.
Catching a little bit more racing action than what I typically do. So should be a good time.
Yeah, it's gonna be fun. Yeah, it'll be fun.
Yeah, very good. So, well, let's get into a little bit of turbo talk.
Sure.
Tell everybody a little bit, I guess, about stainless diesel. I mean, you guys really, you sell a wide range of turbos, anything from like stock replacement kind of stuff to, big S400s. I have quite a few people ask me like, why would I buy a stainless or why would I buy somebody else's? I know you guys pride yourself in a lot of made in the USA stuff. Tell me a little bit about that versus compared to what some other people do. And I guess, some of the things that set stainless diesel apart from the others.
Sure. Basically the, like our 5-blade Mafia kind of series turbos, Trevor kind of came up with the name, and it's stuck for many years. I came up with the 5-blade stuff years and years ago, probably over 10 years ago, to be designed specifically for compound turbo systems. And it cascaded into, what we have today, which is like a plethora of stock appearing turbos and some really aggressive S400 units that do more power than they should for the size that they are. Mm-hmm. And I think that's the future. Just like anything else, you're trying to get more flow through a small space. Mm-hmm. So we started out doing some sled pulling stuff like that as well. More so we're in the daily driver drag racing kind of aspect of things. But when we designed the wheel, we wanted it to be light, and we wanted it to flow very aggressively at mid-level boost ranges. So it moves a tremendous amount of flow instead of being a linear curve, like some of the box units. When you're looking at it, a curve from A to B on pressure, they're fairly linear when you're looking at how the flow works. So ours are a little more aggressive in the mid-range, and then they continue to flow as the pressure ratio increases, but they're pretty aggressive. We've got 75 to 80% of the flow on our wheels in that 40 pounds to 35 pound boost range. So they come on really strong, make a bunch of torque, and they're just different compared to what's out there.
Gotcha.
And then as far as like componentry, we try to utilize as much BorgWarner stuff as we possibly can, but COVID has kind of put the kibosh on some of that stuff. So we had to go out and do some more castings, and it started, during COVID, we couldn't get exhaust housings. So we found some places that we can get some things like that cast. And aluminum turbo covers, we got some new castings there. We've utilized some aftermarket turbo covers because, again, we couldn't get components, and it's challenging, just like your transmission shafts, you probably have a couple different manufacturers that you might try to get parts from, and it's just difficult nowadays.
Right.
So.
Yeah, we have a lot of, transmission parts. We have a lot of the things that we prefer and brands that we prefer, but man, since COVID, you just kind of have to, get what you can. Sometimes you don't have a whole lot of choice, but to use some other brand parts and, just keep rolling. So.
Yeah. So we did a lot of testing on the different components because like our tried and true stuff from BorgWarner, like we know how far we can push those. I know with the data that we have had over the years, we know exactly how far we can get away with what shaft speeds on these things. And some of the new components, we've actually achieved some higher shaft speeds in different areas than what we were able to achieve with the BorgWarner stuff. So it's just that being outside the box or having to jump outside of our little comfort zone that we were used to actually made us better.
So, yeah. Yeah, it's definitely interesting nowadays trying to figure all of that stuff out. And I mean, quality control gets a little bit more interesting with that as well. Um,
Yes.
yeah, it
Yeah.
definitely keeps you on your toes, making
Yep.
sure that everything's right. So,
Oh, for sure.
yeah.
Yeah. And then
What, let's talk twin turbo sizing a little bit. So, um, we seem to get this question all the time on the phones. Like, I want a, 700, 800 horsepower daily driver towing truck. What, I mean, obviously we're still probably on a stock engine and a Cummins application here. What would you guys recommend in that power range? And I guess what's the most horsepower you see on a set of twins and still not have to worry about tearing up a stock bottom end?
so typically, I think that it depends on the engine platform. So if you're talking Cummins based 5.9, I think that we've seen more 5.9s achieve 1,000 horsepower on stock, somewhat stockish bottom end for longer than the 6.7 guys for sure. I've seen a couple unicorns out there. Again, coming back to that stay away from torque stuff.
Right.
Don't hit overdrive on the 8th mile, locked up torque converter with all the boost, and your block's
tuning.
usually pretty good.
Yeah.
That's
tuning can come into play with that as well, and timing.
And I kind of tell people, like, if you're trying to save that bottom end and you have a big set of compounds that's able to make that, 800 to 1,000 horsepower plus, and you're on a relatively stock bottom end, don't give it all the fuel until after 3,500, 3,000 and up. Like, maybe limit yourself to 550, 600 horsepower at that 3,200 and down range, and just let it eat RPM, get away from torque.
Yeah. So. What is your ultimate tow package at, say, 800 horsepower? Like, what?
My absolute favorite is probably, like, if it's a 5.9, for instance, base, your good 5.9 stuff, common rail. I like that 63, 68 little bitty unit, T3 gated, just comes on real quick. And the 480 with a 115 exhaust housing.
Okay.
That combination has proven itself so many times over for drivability. Your ability to tow in the mountains, like going to Rudy's, for instance, that West Virginia little stretches, there's some pretty good little humps out there. And keeping EGTs under control in that aspect, that turbo sizing is great. There's some what I would call mismatched combinations that are out there. You can do like that 62 and a 475, kind of the old school twin turbo, tried and true stuff. When you put it on a 12 valve, for instance, and this is a whole other ball game, when you put the same amount of air in a common rail and say get that 800, 850 horsepower range, and you put that on a 12 valve with, say, ample fuel, you don't get the same horsepower out of the same size turbos. And it's just efficiency, I think, at that point, where the injection system on the 12 valve, static timing, they don't have dynamic timing, and the lower injection pressure. So we could take that same twin turbo kit, and you'll probably make 80 to 100 horsepower less on a 12 valve, for instance, compared to a common rail.
Right. Yeah. So, I mean, obviously, yeah, there's definitely going to be differences in different engine platforms and all that kind of stuff. But yeah, I keep telling people that, horsepower is on a street truck. I kind of feel like sometimes we need to just throw horsepower numbers out the door, and we need to talk more about drivability. I will take a drivable setup that's 100 or 200 horsepower less peak horsepower any day of the week. So that's where twin turbos, if money's not an issue and that kind of stuff, I'll go to twin turbo all day, every day.
Yeah, the drivability on two turbos sized correctly is just day and night difference. Like the hot turbo nowadays is like a 468 or 467.7 for the big single, and they do relatively well. But you're missing so much low end torque and drivability.
Right.
It's crazy.
So how much difference do you see in an S400 on the manifold versus an S300? So say you have a 463 T4 on the manifold versus a 363 on the manifold.
Sure.
At what point do you switch from a 300 frame to a 400 frame, and what's the drivability difference that you see?
So typically, it really depends on a customer's overall goals. But like if it was a 6.7 cubic inch motor, and rebuilt versus a 5.9, apples to apples or apples to oranges. I like the 400 on a 6.7 base because the drivability is there. Lower end, the strength of the turbo charger platform is a little bit better, more resilient on the bearings for the 400 system. But on a 5.9, I like the 300, 400 better. If it's going to be something you're actually going to tow a 44-foot gooseneck trailer through the mountains with, or a big fifth wheel trailer, it just works better. That you can lug the engine at a lower range and still keep real good drivability. We did a lot of testing years ago on a 463, for instance, 465, 464. It's the same turbo. Borg Warner, that's another question we get to, and I'm sure you guys do. It starts as a 169012. It's a Borg Warner turbo. It's a 464. If you look them up, Borg Warner calls it a 464. And I think the Sled Puller guys kind of call it a 465 or started 2 years ago. Is if you plug those things, they'll measure 2.56-ish in the bore a lot of times, so almost 65 millimeters in the bore size. And then the wheel is actually just a hair under 64 millimeter when you're measuring the wheel. It's hard to measure it because it's a 7-blade, but it's like 63.8 millimeters in that range. And it's hard to find a flow map on this turbo. This is another misnomer that I see. It's a great little unit. We sell a bunch of them, and they're very strong pieces. But I've seen different dyno numbers on them, and I've seen different flow maps on them. There's one flow map that Borg had that does 70 pounds a minute. There's another one that I've seen that did 65 pounds a minute. And keep in mind, they test this thing with like a T6 110 exhaust housing. That's what comes on it. It doesn't come with a T490 like everybody thinks they do. But typically, when you choke them down like that, you get a little less mass flow quantity through the turbine wheel. But when you look at a 63, 68, that moves from Borg Warner in the SX3 version, which is like the cash wheel, your basic before the SXE. That unit does 75 pounds a minute, and the rotor group is lighter. So the turbine wheel, compressor wheel is quite a bit lighter, responds quicker, and it moves 5 pounds a minute more according to maps that we've seen from Borg. So both really good units. But the bearing system in the 400 is definitely more resilient to taking abuse.
Yeah. Well, I mean, we had pretty much, back in our diesel power challenge days, we would exclusively run the 300, 400 setup, and we loved it from the drivability standpoint. But we were also, a good bit of 5.9 stuff back then. But then even on the 6.7, I mean, it would make a ton of torque, and it was extremely drivable. And I mean, it was about the only thing we did. And then we kind of got tired of tearing up S300s, but we were pushing them to, 13, 1400 horsepower with nitrous sometimes. So it was more than what they really liked. So from there, we pretty much, almost exclusively went away from the S300s on the manifold and, just did S400, 400 side by sides. And some of the thing that I like about that as well is the serviceability and taking apart an S400 versus an S300. You've got nice V-band clamps the whole way through. You don't have all those 8 bolts on the back of the cover. Minor little things, nothing crazy. But I have talked to you guys some recently about some twin turbo sizing, and you guys recommended the S300 on the manifold for a 5.9, and I was like, we may have completely written those things off a little bit too much, because on a 5.9, it really, it does make a pretty decent difference on how quick they spool. And they're still pretty robust turbos, and you can make an 1100 horsepower setup reliably without even thinking twice about it.
I think the biggest line that I would draw is kind of like what you mentioned earlier. You guys had trouble when you got a hold of nitrous with the S3, S4 combo. I think that's a big delineation line for me. If a guy's going to say, hey, Johnny, I want 1,000 horsepower and I want a twin turbo and I'm going to spray nitrous at it. My first thing is you want 2 S400s minimum. And then the sizing comes into play for sure. But the 300, if you're not going to spray nitrous, we've seen ridiculous horsepower out of the 300 combos. We've done like we put 85s with those on some king of the street vehicles. There's a pretty nasty black dually out there.
Yeah.
And we did a T410. We did an SX3 based unit for S300. We did like a 6674 turbine, but it's the SX3 turbine has a little bit of what we call a flow clip on it. And what it does is it lets dry pressure out. It takes a little bit of, I guess, what you would call turbine efficiency away in the lower end and shifts it to the higher end. So it's kind of like having a big camshaft in a Chevy LS motor. And, you might lose some torque, but you gain some top end.
Right.
And on that unit,
because you're not restricting your engine airflow as much.
Exactly. So basically you don't have an exhaust plug you can shove it all in the engine, but if you can't get it out, you're not going to see the gains that you're expecting. So with an 85 on it, on the engine dyno, on that particular 5.9 engine, it was in that 1620 horsepower range at the crank. So it's pretty impressive for a little 5.9 and an S3, S4 combo.
Right.
Crankshaft wise, but it's something you just don't see. A lot of people are, like you said, went away from the 300 platform in some aspects, but the drivability is just awesome.
Yeah.
5.9 for sure.
Yeah.
And
so we touched on it a little bit there, but let's talk a little bit more about turbine side, turbine wheel sizing and exhaust housing sizings. What are your go-tos for, a towing twin setup as far as on the manifold turbo and on the atmosphere? I guess let's start with that one. So then we'll dig into it a little further. Maybe
I was going to say, again, it kind of comes down to, is it a 5.9 or 6.7? D&J has done some really neat little combinations with some heavy vehicles with some of his 6.7 engines. We've tended to go 300, 400 on that stuff and that 850 horsepower range. And it sounds kind of like a little backwards from what you typically hear, we do a 465 and a 480, for instance, on a 6.7. But on these combinations, you can take an S3, S4 and a 6.7 and still achieve good power with correct turbo sizing.
Facts.
Yep. So like the exhaust wheel sides, for faster response, if you make your rotor group smaller, so smaller turbine, smaller compressor, you'll get more response time, better lug, better torque, but you choke off the top end, in general. But like go-to stuff, basically for a 6.7, say 800 to 1,000 horsepower, maybe even cracking that 1150 range. We've done 468s and 465s with a 480 and a 115. And we've seen anywhere from that 1,000, 1,100 range, good drivability on 6.7 stuff, where you still could do that with a 480, but I tend to go on a 5.9 back with a like a hybrid, we call it. So a 63 compressor, but we go with that 74 turbine, 73 turbine for the S366. You would typically have that turbine on it. And we did that years ago in testing, spool ups quite a bit better with a 63 compressor side. But all your dry pressure gets to come out and your power is really good on a 300, 400 that way. It's kind of a trade-off.
Right. Yeah. And I mean, some of this stuff that we're talking about, I know will probably fly straight over some people's heads, but I think it kind of comes down to, you have some people that call up and they're like, well, I have this turbo and that turbo. Will it work? And yeah, it'll work. But I think this is why it's good to call a company like you guys and be like, hey, I've got an 800 horsepower goal. I want to go towing with it. I want to race it occasionally. What do you recommend? And I think you guys are really good at putting sizes together. I don't know. People sometimes will try to save a penny trying to piece their own turbos together. They don't know what the backside is. They don't even, all they worry about is the compressor size. I have a 63 millimeter. Okay, well, what about the rest of it? Like, what's it made to do? Yeah.
No, for sure. That's one of those things we run into. I forget what it was, not too long ago, actually. We had a turbo that was not responding how it should have on the dyno. And come to find out, I think the gentleman that was running the dyno found out that it was in a 87 turbine housing instead of an 83 turbine housing. So that some of that stuff can get missed if you just
I think we had that
happen. Yeah,
I think we had that happen recently where somebody, just like it was a not performing at all like it should, and come to find out it had the wrong turbine housing on the wrong wheel.
Yep. Oh
So
yeah. Yeah, it's kind of wild. Like we've done testing with clearances. So, when we're doing these things, people look at the turbos and, they see how close they are. The wheels are actually to the bore, and they'll grab the shaft and wiggle it. And, oh boy, this thing's loose, it's a little wiggly. And then I try to tell guys too, it's like, you're supposed to have some movement. It's kind of like your engine crankshaft thrust, need to have some thrust movement. But when that thing has oil going to it,
right.
it's hydrodynamically supported very strongly. If you ever grab a turbo, which you shouldn't, not recommending it, and start the truck, which I've seen people do to break them in, kind of not let the shaft spin, and I don't recommend that again. But when you have a hold of the shaft and start it, it's super stable. You can't put it off axis very easy when you do that. So it's just one of those things that's people that haven't been around turbos a lot get a little nervous when they wiggle it around. And
pretty much when you grab a shaft of a turbo, you can have some side to side wiggle, but typically you don't want in and out wiggle. That's when things get bad.
So we get nervous when you have thrust movement, so the in and out. And basically the reason why is when you look at the compressor wheel, it's kind of like just a big curve on the backside that you don't see when you're looking at the air filter area. And there's only, depending on the size, talking S300s, I mean, it could be as tight as 10 thousandths to 12 thousandths off the cover. And if you feel like your normal board warner thrust clearance is in that 3 thousandths range, 3.5 thousand roughly on a brand new turbo, that's something that's hard to feel. If you're not feeling it correctly, it could move off axis, things of that nature. When you start feeling a plunk, that's typically going to be 6 or 8 thousandths. And if you let it go much farther than that, the wheels will actually rub the inside of the turbo cover and get into the exhaust housing, and makes it a bad day. So.
And that's some of the balance you as a turbo manufacturer have to ride that fine line of getting a tight clearance so that you get ultimate performance, but yet you don't want it so tight that you quickly run into wheels getting into covers, because that's a bad day.
Oh yeah, it's definitely a bad day. I know testing clearances on the exhaust housing, so there's some interesting data there. And then one thing I wanted to mention when we talked about twin turbos, for instance, the sizing thing. So us, having good data like the ECMs with the Bosch, and like you guys do, you can see all kinds of data that you normally wouldn't see in your daily driver. For instance, shaft speed, compressor discharge temperatures. One thing that we do see in a compound system, see that we went from a 63 compressor to a 66 compressor in a particular combination with the 480 or 485. The larger the compressor on the manifold, so the small charter, in the two-stage air compressor, the bigger the compressor, the lower the discharge temperature typically is, and your interstage pressure will drop by a few pounds. It's more freely flowing through there, but you can trade off some drivability on the lower end by doing that in certain situations. So that's interesting data side. And then back to the clearance issue, or clearances, they're real critical on many aspects to make them efficient. One thing that we have measured is trying to play with clearances on the turbine housing in the curve. So that's, there's an inducer, exducer. So there's a major portion of the wheel, and there's the bore. When you have too much clearance on an exhaust housing in the curve of the turbine wheel, your drive pressure goes up. So it's kind of interesting. What took some turbine efficiency away from it, so it slows down the shaft speed a little bit.
Okay.
And drive pressure can get higher because it can't evacuate. So there's some interesting stuff there. Yeah.
I can only imagine how much things you can learn just from testing. I mean, fin count, fin angle, clearances. I mean, there's so many roads you can go down. You could probably run yourself to the poorhouse testing things. And
turbo cover ARs might be a thing to think about too. Like the large covers and the small covers. We've tested quite a bit of that, and there's some power differences there for sure.
Yeah. So do you guys get into, like, what do you guys cut in-house? Like, I know you do some
Yep.
flanges and some things like
Sure.
that. Do you get into turbo part manufacturing in-house?
So what we'll do is we'll cut like our turbo cover profiles, for instance. So the curve, say we want to take a smaller cover and we can machine it to a bigger cover profile. So we'll do some of that. We will take the compressor wheels. Sometimes we'll have a batch of wheels that are made a bit oversized.
Okay.
And then so that we can utilize them for multiple different sizes, for instance. And we will turn the compressor wheel profile on the lathe as well. So we got a Haas CNC lathe, and Junior and I run the lathe mainly. Steve here's been learning a little bit, jumping in and doing some pocketing. So the pocket of the bearing housing where the wheel sits in the recess. So that's a thing too. So clearance on that is real critical as well. As far as the manifolds, we'll machine the manifolds in the shop. I'll end up doing a lot of that stuff. And then we do our spacer plates, our little 1-inch thick spacer T3, T4 adapters, things like that at the shop. And then our flanges for the downpipes, we'll machine those too.
And
so,
you guys
a
will
lot of that stuff.
Do a lot of the machining on your manifolds as well, or is that?
Yes. Yep. So we'll take the raw casting from Muskegon and we will just put it up in the machine. I do a lot of that stuff on Snap, I guess. I don't have a whole lot of that on the internet. I think we might put some of that on TikTok here and there.
Yeah.
But we did. It's basically it's got a 4-axis Brother CNC machine. Okay. And we'll machine the manifolds 2 at a time. And we could do, the T3, the T4, and then T6 footprint all on that one machine. So it's a neat piece.
Yeah. So serious question here. Does Steve do anything around there other than just like goof off on people?
For the most of the day, he's on the phone. No. He's a great addition to the team, man.
I bet.
Yeah. He's he's a comedy relief for the shop for sure, which is awesome for everybody. And then we all kind of pick on each other back and forth in a healthy manner, of course. But
you guys definitely seem to have an interesting cast of characters, and seems like you guys have a good bit of fun with each other.
Oh yeah, you got to make it fun. That's for sure.
I'm sure you guys never get on each other's nerves, and it's like a perfect happy family, right?
Oh yeah, no, not always. You know how it goes. There's good days and bad, but mostly good.
Isn't it crazy how, just doing business with people day in and day out. It's just, you learn, I guess you learn everybody's crap stinks, and you definitely find it out at work.
Oh yeah. Yep. But no, it's a good time. Yeah. The guys back at the shop, just something else,
Yep.
But our version of Cody is Eric, and he does a lot of the welding and downpipes and some twin turbo stuff and jigging up everything. And I used to be the wear it all the hats guy, and welded everything and fabbed it. And so we got some good guys at the shop. And Steve's mainly building turbos now. Okay. And so doing tech on the phones, all of these pesky electronic gremlins that seem to plague some of these electronically actuated turbos. Steve's really good at sorting some of that stuff out. So.
Yeah. Seems like there's just never quite enough tech support or phone support to go around. I mean, it's a thing. However many people you put on the phone, their phone will probably be ringing, and you can sit there and answer questions all day. And it's such a tough thing to balance sometimes. It's
very difficult.
Yeah. I mean, you want to support your customers, and yet there comes a point in time you just can't do it all.
Yep. So. Yeah. I could consider ourselves still, just a small family run shop. We got a good handful of great people there. And then we try to catch all the phone lines that we can, but there's just sometimes we can't get it. The best thing to do, it's wild. I can answer probably 50 emails in an hour, but I can't get 50 phone calls in an hour.
Right.
I don't know how else to explain it that way.
Well, we've started relying pretty heavily on email and text messages. I mean, the thing with text messages is you can, if you're on the phone, you can answer a text while you're on the phone, and or it's a lot flexible that way. And I understand, like, when I call or I'm trying to get a hold of a business, like I go through the same thing. Like, I want to talk to a person, but sometimes it's just, there's more than what you can handle, and you just kind of got to do what you can. So.
Oh yeah. Yep. Heck yeah.
Yeah,
It's a challenge, that's for sure. I think we're all the business guys, that are in this arena, I think have went through that a time or two here and there. But we try to do the best we can and try to help all the customers achieve all the goals that they want to be at. The racing has really taught us a bunch about. It's kind of neat to see the people and seeing firsthand,
Right.
and they see what you can do on the track and they're like, well, I want to do X, Y, and Z. And can you do that? And like, yep.
Yeah.
So it taught us a lot on how to do different managing power differently too, over the years, like you said, stay away from torque and keep your parts happy.
Isn't it crazy how, it's so night and day different what we're doing on the track versus what you're doing with the daily driver truck, but still the amount of things that we learn from that data, it's literally almost like going to a dyno every weekend we go racing. There's so much stuff that you learn, whether it's, how, heat versus turbo shaft speed or, different things like that. You can learn tremendously, but
that's a huge deal. Yeah,
pretty crazy.
Yeah, the thermal energy drives the turbine more so than just exhaust flow, and that's what we try to stress it to people a little bit. And then like the turbo stuff, we like to keep our hot pipes really short, and we feel like it drives the large turbo a little bit harder. And we learned that on the Duramaxes. So we could take the same size turbos, for instance. And the Duramax has a V8 kind of engine, instead of an inline, and they'll mount that big charger way out on the front fender area. And then you've got probably about a 3 foot long hot pipe or longer in some cases. And when you make that pipe really long, your big charger, like your normal 70 pounds of boost range, you might only make 20 out of, say, your big charger instead of, half pressure. We try to get close to half pressure as possible. That's what we like to see. So if you're making 80 total, we want the big turbo to make 35 to 45. And that varies a little bit on, turbo sizing, housing sizing.
So talking about thermal energy driving a turbo, I know I've talked to you before about the differences in stainless versus mild steel, and as far as like holding that thermal energy, talk about that a little bit and what you guys have found there.
So a big thing on the stainless steel we have with the manifolds, it's a 400 alloy, so it is magnetic. So some like engine valves, for instance, are non-magnetic, more like a 300 series stainless. So we did testing years ago before we cast this thing. And 300 series material, especially in a cast form, tends to, after multiple heat cycling, it pretty much continues to harden itself. I guess it's not really a work hardening, but it's essentially heat treating itself every time and making it brittle. Where this 400 stuff is a little different with the alloy that we utilize. So it doesn't typically change its makeup after multiple heat cycles. Neat thing about stainless is it retains thermal energy, where cast iron will let the heat out quite a bit faster. And then as far as moving things around, cast iron gets hot, and the old 12 valves used to break the ears off of the old 12 valve heads. So then the 3-piece manifolds kind of came into play there to make them not do that. But the cast iron was always kind of prone to cracking. So the stainless doesn't tend to crack. It's very rare that you'll see it do it. And then as far as the 400 alloy, but the 300, you can definitely have some embrittlement issues with that. But as far as longevity and thermal, keeping the heat in, the biggest thing a customer will see is you take your cast iron manifold off, you put our stainless diesel one on it. And when you go to idle it and cool it down, if you had a turbo timer, for instance, it may not cool off fast enough. So it'll hover around 400 degrees for a while. And that's something that just retains all of the heat. It doesn't want to cool off. So very easy.
Man, turbo timers are kind of a thing of the past. I remember when that was all the rage.
They used to be super hot.
Is that just something people have just decided it's not necessary and so they don't do it? Or is it?
Well, I wish they'd bring them back, just knowing that we see the turbos come in, and the turbos tell us the story. I'm sure when you guys see your transmissions apart, you'll say like, well, I know how that happened. And it's one of those things where you can see the heat propagate from the turbine wheel all the way up the shaft to turn gold. it'll turn some different heat colors.
Mhm.
And guys that do hot shutdowns, there's some interesting bearing marks that show up too. Basically the journal bearings in a 400 or 300, they're just like that bearing brass kind of material. If you shut it down hot, the bearing will actually swell up in the bore and thermally distort itself into the oil feed passage. So there's a kind of an oval shaped oil feed passage that Borg Warner, different turbo manufacturers will machine into it. And that bearing will actually swell up and push into that feed passage. When it pulls off, that's a small high spot that'll drag that bearing in the board as you start it back up and run it. So if you do that enough times, it definitely causes a premature failure.
Okay.
So
after running your vehicles hard, a bit of idle time is definitely a good thing to do.
Yep. Let it idle twice as long as you think you should before you shut it off. That's all I could say.
Yeah. Yep.
So your turbo will thank you.
Yeah. And then there's always the oil feed and oil drain discussions that seem to happen. You probably have those 10 times a day.
It's very interesting. Yep. I think Levon asked me a pretty good question the other day about that. Why do some turbos leak when you put a -6 line on it, and others won't? The drain side is huge. I think a huge misnomer. Everybody's like, well, I got that -10 oil drain. It's kind of like cylinder heads. I got a set of Chevy cylinder heads, but not all the ports are the same. So that back in the 12 valve days and the VP days, they had a 7/8 inch drain line on them. So 7/8 inch hose, would plug on that line, and it's a 16 gauge hose, so about 60 thou. So times 2, because you got 2 walls of that diameter. So the ID of that pipe is 750 thousandths on an HX 35. So all these new -10 lines that are coming in at 470 thousandths and 500 thousandths, like less than a half inch.
Right. Well, I mean, when you think -10 line, when you think -10 line, you think 5/8 line, but the ID of the line itself, you're seeing like 0.47 on some of the line.
So it's typically the fitting, I guess, that would bolt to the turbocharger. And then different line manufacturers have different inside diameters for sure. Like your general A&N Army Navy size should be kind of what it says, but it's not always the case.
Right.
So from what we've
seen. I mean, what's the smallest fitting size that you've seen on a -10 line? I guess typically.
I think the smallest one I've ever seen was a 450 thou on the inside of the fitting. As far as the line size goes, they won't vary as much as the fittings will. I think the most successful fittings that I've seen are in that 630 thousandths at the fitting size, and it's a little closer to that 5/8 line size.
Yeah. No, I've definitely started paying attention to line size and fitting sizes more with the nitrous systems.
Oh yeah.
Drill bits have become my friend for measuring fittings.
That's a great trick.
You throw the drill bit in there and you put the biggest one in there and you're like, okay, well that's what. But my -8 lines that I think are flowing, a good bit of nitrous, I come to discover that, I've got some pretty small orifices in there in my fittings. So talking with Tony Durhammer a little bit and comparing some sizes from different brands of lines, there's definitely a pretty big difference there. So something to pay attention to, whether you're plumbing oil drains or nitrous, definitely something to pay attention to. But on the feed and drain thing, I mean, we've kind of, as a whole, just moved to -4 lines. Do you see that being a bad thing at all? Or
in general, if it's a compound system, for instance, you're already turning, say, 60% of normal shaft speed, 60-70%. Your manifold charger typically will be about 20% slower shaft speed when you're recompressing it in a compound system, roughly, give or take a little bit depending on sizes. But on a 400, we really do like to run a -6 line. The -6 fitting at our oil filter head, the one that we send, will pin gauge at just under 200 thousandths. So it's not a full 250 thousandths like we'd like to see, but not every motor can handle that kind of flow. But if it was a sled pull guy, we'd say, yep, you want to open that up. And we've got data showing that in a 400 Borg Warner turbo, if you're at 125,000 shaft speed, -4 seems to work, okay. If you are above that, which is very easy to get there, say 135,000 to, I don't like to see a board Warner turbo go much over 135,000, but we've ran them in sled pull stuff to 145, 144, and it will prematurely fail bearings up in that range, but we like -6 feed line to help it. The main oil feed galley is 260 thousandths. So if you got one apart and you're looking at the feed passages, it's relatively large. Back to that aspect of why do some leak more than others? There's so many different bearings out there. There's the 360 thrust bearing that everybody talks about, as opposed to like the 270 thrust bearing. So not all thrust bearings are created equal as well. So there's some aftermarket manufacturers that make different ones. If I put an oil pressure gauge between your oil filter head and the turbo, for instance, and we use a super fancy 360 thrust bearing that might have some different hole diameter sizes, and put it in there as opposed to just a box board Warner thrust bearing system, you can lose up to 10 pounds of oil pressure just by doing that. And you're like, wow, okay, so less pressure, something's freer flowing somewhere. So hydraulically, when you're looking at the turbo, when the oil freely flows out of the thrust bearing, because of the thrust bearing design, typically, you starve the journal bearing in the rear of the turbo. So it'll turn black, it'll gall up, it'll season the bore. Thrust bearing will look beautiful though. Doesn't help the rest of it, but there's a balance when you're doing that bearing system. So some of the bearings will flow more oil through them, and which can cause, the oil drain, if you had a small drain size, to have more issues. Typically, if you're seeing oil come out the front and the back of the turbo, then it's more than likely a drain issue versus volume going in, gravity drain, pressure feed kind of deal. Yeah. But the bearing system can have a huge effect on how the turbo drains. Gotcha. Or its ability to. Yeah. So.
Man, I'm finding there's turbo things we could talk about for quite a while.
Lots of info out there for sure.
Lots of info. I wanted to talk a little bit about external gates yet. That was something that somebody mentioned on last week's episode. Tell me, I guess they were wondering when to use them and how to use them. I'll talk a little bit about kind of our journey with them, I guess you would say.
Sure.
We first used them back in our diesel power challenge days. We had gotten to the point where we thought we were putting more nitrous in than what our turbo setup could handle. So we put gates on it. Well, we didn't, I guess, understand how to control them. And it lasted all of about 2 dyno hits and nearly cost us the dyno. And we just blocked them off and said, we're done with them. And we said, we hate external gates and we don't need them. We're going about our merry way. But now doing, race truck things like we're doing now with a lot of nitrous and a single turbo, we're back to needing it. And we've learned a little bit more about them. I still don't think that, I know that we don't use them to their full extent from the standpoint of using a solenoid and opening and closing them with dome pressure and that kind of stuff. So pretty much, I don't even know where to really start on explaining these, but for the most part, there's an internal spring that holds the puck down on the seat and keeps it shut. And those vary some from different manufacturers, but the Turbo Smart one is the most common one. And I think a lot of those have a 45-pound spring in them, if I'm correct.
Yep.
And then, so that's kind of a start, but we've learned that on our high horsepower applications, that's not enough. If you let that blow open, you're going to waste a lot of horsepower. So you do need to put some pressure to the top of the dome to help keep that thing blown shut. And kind of what we've come up with on a race truck application is we really like to run a regulator off of our nitrous system, and pretty much the regulated nitrous that runs our shifter and our parachutes and stuff. So we're at like 100 PSI. Yep. We run that to its own regulator as well for the wastegates, and we'll set it. I think the S10's set somewhere around 35 psi right now, and so now we have a constant pressure source that we know will consistently, keep the same amount of pressure on the top of that dome. So that helps hold it shut. And then once the pressure overcomes the power of that dome pressure, then the gate can start coming open a little bit. So we're using it in a very static kind of a state, where I know some of the more advanced setups will use a solenoid where they're actually opening and closing it to help control power. But so that's kind of a quick rundown of that. But tell me a little bit about your experience on it.
Sure.
And I guess talk about it in a race application if you want, but then let's also talk a little bit about, like, at what point do we put an external gate on your daily driver / race truck?
I guess for the most part, wastegates are a great, useful tool. They can be problematic and they can be frustrating at times, for sure. But as far as the TurboSmart brand, I mean, great brand, great parts. We've had very, very good luck with those. I think in the diesel world, most guys are utilizing that 35-pound or 45-pound spring. My recommendation typically is, if you're going to spray nitrous, and obviously up to a certain point, you can get away without spraying, without a wastegate on certain turbo sizing, like Greg Albarella, for instance. His black truck has some smaller units, like some BorgWarner, like 76 millimeter stuff, and he sprayed its face off. I think with just 2 kits, I think at the time with the maximizer stuff, and just turbos didn't last long. We did an 80 millimeter 96 turbine with a 115 housing, and just as a single, and that's what's in his black truck now, but we added some wastegates to it. And he's been in that 1,650 horsepower range calculated with the weight of the truck and like his 8th mile, 595 passes with his mile an hour. And with 2 wastegates kind of hanging over on I think 3 kits of nitrous, I think at that point, three small shots, if I'm not mistaken. But I think when you're going to spray a substantial amount of nitrous to anything, I think wastegates are definitely your friend. And that's when I recommend starting to get into the wastegate arena. Years ago, a lot of guys were doing twin turbo kits and adding a gate for the manifold and trying to gate around that. And what we found is that it was not necessary if you size things right in that aspect. I think big single stuff, lots of nitrous, definitely your friend. We do some turbo car stuff. So we got turbos on LS stuff. We've got them on big block Chevys. We've got the drag and drive kind of cars with some of our stuff on there. In a lot of the gas world, they're doing a really elaborate regulation. A lot of it is Holley EFI, basically controlling MAC valves. So just your little air 12-volt valve, and they'll have some feedback. And I've seen guys use the small air compressors, like you run an air horn system with. And they'll do that 100 pounds, and then they'll regulate it down with the sensor feedback and try to keep a boost curve up, or they'll, instead of blow the tires off on the front half of the track, they'll program in a boost curve so they can get down the track. So it's a neat system, but a lot of different ways to skin a cat.
Right. Well, and as far as like holding that gate shut with the pressure, like we like to use the nitrous, but you can use boost pressure to do it. The main reason we kind of went away from that is because it's really hard. It was really hard to set a regulator when you don't have, I mean, you kind of have to do it live. Like you're kind of, making a run and seeing what it does and then making an adjustment. Whereas this way we have a lot easier way of like, hey, I've got 35 PSI to the top, and then I can tell what it's going to do. Whereas if you don't have, I mean, I guess you could take a line off. Well, you can figure out where your regulator's set by popping your boost reference line off of your pipe and, putting air compressor air to it and seeing what your regulator's set at. But that's kind of a pain. Like it's not just a quick adjustment to make, you're always getting the air hose out and taking a line off. And but I realize not everybody has nitrous on it. Well, then again, according to the recommendation you made, if you have nitrous on the vehicle, you need a wastegate. So maybe
for the most part, yes.
Maybe
we get away with some nitrous.
Yeah.
But typically, if it's not a large single, like I don't want nitrous on a 7287 without gates or anything that size or smaller. Typically.
Yeah. So let's talk a little bit about single gate versus dual gate. I think, I mean, for me, a lot of the reason for going with a dual gate would be because of the twin scroll and the divided turbo. Do you see, like, are there ways to do a single gate with a divided scroll decently? Like, does it matter about the exhaust gas mixing in that area? Is it not significant enough to worry about?
There's definitely there's been testing done for sure. Years ago, I guess, there were definitely a number of manifolds that were machined and kind of made where you could breathe, say the right side of the manifold and the left side of the manifold over top of the divider, would basically cross flow back and forth. And I think Ryan Milliken did a really neat test years ago. And I think I had another customer do it. Its name escapes me at the time. But it definitely affects the torque curve. It affects spool up when you have all those power pulses not separated, like in a divided housing, for instance. On some tractor pulling stuff, engine dyno tractor pull stuff, we've seen a good amount of power loss. These tractor guys, TT 466 stuff, 470 cubic inch, S400, 3 inch by 3.5 inch kind of tractor class. They would take a T6 adapter and put on their tractors, and most of them were some open kind of apparatuses. So the manifold's divided, the spacer was open, and back to a divided exhaust housing. They would literally lose on a 1,200 horsepower tractor. They could lose 30 horsepower by just doing that in a 1 inch space. So there's a lot of neat things you can do, but being divided, I always recommend stay divided. It drives the turbo quite a bit more efficiently. And with us diesel guys not being horsepower, a lot of RPM at horsepower rather, being divided is definitely your friend.
Yeah, no, that's what we found for the most part. Definitely a good thing to keep things divided when you can. And wastegates can be your friend, but there's definitely a learning curve to them, and they don't get tuned in overnight all the time. One of the things that we fight with wastegates some, I think we were actually just fighting it at Indy, I don't know what you would call it, not the bellow, but the I can't even say the word.
Diaphragm.
Yeah, the diaphragm.
Yeah.
The diaphragm blew out. And so anytime we turned nitrous on, we had a nitrous leak in the wastegate because it's just blowing through the diaphragm. So that's a maintenance item. Heat gets to those eventually. And
gets them hot and they're done. On the Pro Street truck, we basically let it ride the springs. We tried to hold them shut at a certain point, but we're basically on a kind of a smaller turbo. That way, if we had to pedal, which we typically would have to pedal with that crazy monster on occasion, the shaft speed would get crazy. 88 millimeter deal, and shaft speed in that 124, 125,000 range. If the gates weren't open, that turbo wouldn't last long. So,
well, and that's kind of how we did it on the S10. Like, we got to the point where I don't remember what year it was that we blew up that turbo at the last race at Virginia, out there at the PDRA exhibition thing. And so we knew we were overspeeding the turbo. So we added gates to it, and we're going to go right back at it. We figured, we'll just put spring pressure, let them blow open, do their thing. Well, man, mile per hour was way down. So we learned pretty quickly that we need to give this thing some help, staying shut so that we can, hit the target of keeping the turbo under control, but still not lose too much power. So obviously it depends a little bit on the application, how hard you're pushing something, what kind of back pressure. We could get into talking about your engine being an air pump and getting air in and out and all that stuff. And we could probably talk for hours about that yet too. But unfortunately, I'm kind of up against the clock here. My kid's got a hockey game tonight, and if I don't shut up here soon, I think we might run late. But it's been a good chat, and it's made the hour go by quickly. So just in closing, though, I've got a couple of fun questions. We'll play 2 quick questions of Would You Rather. I played this with John Mellon the other week, but the first one is, would you rather ban wheelie bars for the rest of your life or ban track prep for the rest of your life?
Ooh. Well, now that we have a car that recently has wheelie bars, I'm going to say, it's hard. Boy, that's a hard one. I'm going to say track prep.
Yeah. I think that's probably where I would go. You can put wheelie bars on something and you can figure out how to get it down most any surface. It might not go as fast as you want.
Right.
But yeah. So, and then the second one, we'll personalize this one a little bit. So would we rather lose the ponytail or not go racing for 2 years?
Oof. Wow. Well, that's a great question. I'm going to say the ponytail's going to have to go.
The ponytail's going to have to go.
I got to
you
go
like
racing.
it, but we're going racing.
Yeah, that's right.
It's a good answer. There's no right or wrong answer, but I just thought that'd be kind of fun. So,
good stuff.
Well, thanks again for chatting with us. It was a good time, and hopefully we can educate some people and have a good time in the process. But I'm sure we'll catch up with you here in the near future, and we'll see you in a couple weeks.
Yep, we'll see you at Rocky Top.
Cool. Thanks, Johnny.